All right, the question says, use the quotient rule to find dy dx. Simplify your answer. The function is y is equal to tangent over 1 plus cosine x. So let's first review the quotient rule. If you want to take the derivative of a rational function, f of x divided by g of x, given g of x is not equal to 0, so we are working under that assumption, then what we do is low d high minus high d low all over low squared. So what does that look like? Low is g of x times the derivative of the high minus the high times the derivative of the low all over low squared. Let's put that in brackets. Okay, so we need to apply the quotient rule to this function to find the derivative. All right, so let's clean this up and find the derivative. All right, so the derivative dy dx is going to be equal to low, which is 1 plus cosine x, times the derivative of the high. So the derivative of tangent x is secant squared x, and then minus, so we got low d high minus high d low, so minus tangent x times the derivative of 1 plus cosine x. The derivative of 1 is 0. The derivative of cosine x is negative sine x. So now that's all over 1 plus cosine x squared. So we don't want to FOIL that because we want to simplify our answer anyway. The beauty of trig is there's so many different ways of representing the same quantities, and therefore we just want to simplify just a little bit to make it look a little nicer. So in other words, at the top of this, we have 1 plus cosine times secant squared, and then that negative tangent x times negative sine x. So let's clean that up a little bit, and we may get to a point where we can factor something out and make it look really nice. So the first thing we want to do is distribute that secant squared. So if I multiply secant squared by 1, of course that's secant squared x. Secant squared times cosine x. We'll keep it written secant squared x times cosine x now, but you should know that cosine x and secant x are reciprocals. And so in a second, we're going to change the way that secant squared is going to be written. So cosine x times secant squared x. And then finally, these two negatives right here are being multiplied, so that's going to result in a positive. And now think tangent is sine over cosine, and therefore if I take sine over cosine and multiply by sine, so let's just show it, sine x over cosine x, and I multiply by sine, that's what that would look like right there. Okay, and then of course over 1 plus cosine x squared. And now there's so many different routes you can take, but here's what we want to do. We want to just reduce a little bit, just do a little simplifying here. There's some things that we can clean up, make this look a little nicer. Now we don't want to continue to change things around because like I said, there's so many different ways of representing the same quantity using trig functions. Therefore, we just want to clean it up just a little bit, but don't try to simplify it so much where you make mistakes. All right, so we have secant squared. Now, if I go here to this second term, remember, secant squared is equal to 1 over cosine squared. So if you have cosine x over cosine squared x, that will reduce to 1 over cosine or secant. And then finally, sine over cosine times sine is going to be sine squared over cosine x. All right. And then, like I said, remember, the idea is just to simplify it. So we're just going to, clean it up just a little bit. All right. Maybe 2 more steps and we'll be there. And so now what I have in that blue color, so let's write everything else, secant squared x plus, well, this here can be reduced to 1 over cosine x, right? Because you have a cosine x at the top, cosine squared at the bottom. Therefore, one of those two cosines can be reduced. But instead of writing it as 1 over cosine, I instead want to write it as secant. So that in purple can be reduced down to just a single secant. All right, and then at the same time, this cosine in the denominator there could be considered as 1 over cosine because that is in the denominator, and therefore I could use the reciprocal function secant there as well, and I'll have secant x times that sine squared x. And so now I have no denominators in all those terms in the numerator. All right, and now let's keep scrolling. So now all those terms share a secant. So I could actually factor a secant out of those 3 terms in the numerator and have secant x factored out. And so here, if I factor 1 secant out, there'd be 1 left. So this would be a secant x. If I factor a secant out of this term, of course, secant divided by secant is 1. And then if I factor a secant x out of this term, I'd have plus sine squared x. And all that is over the 1 plus cosine x squared. And then that is sufficient enough. As I mentioned, there's so many different ways that you could represent this same quantity. We could continue if we wanted to and take this secant and think of that as 1 over cosine and bring that to the bottom. So there'd be another cosine at the bottom, such as this. And again, there's so many other things that we can do, but the idea is to just simplify your answer so that if you go back to the top, it looks a little better than what it did whenever you first did your quotient rule. All right, so these would be both acceptable here, but there would be other representations of the same derivative that should also be acceptable. The idea is to simplify your answer and make sure you know your trig functions.